carrying on with this polymer thingy me bobby. Right, so you've got from question 6, alkenes are unsaturated. What does unsaturated mean? It means a molecule or the molecule that we are talking about contains a double carbon to carbon bond. Right, one method of producing alkenes. Remember, alkenes have a double carbon to carbon bond. So alkenes are a type of unsaturated compound. Complete the equation for cracking. Cracking is where you break down large hydrocarbons into smaller hydrocarbons. Of dec means 10, into oct means 8, and ethene. Remember I said you need to know ethene. So monkeys eat peanut butter. 1 carbon atom, 2 carbon atoms, 3 carbon atoms, 4 carbon atoms. We're after ethene, so we've got 2 carbon atoms, and because it's an ethene, it's got a double bond, and then I'm going to do it this way. We've got 4 hydrogens. Right, so they've said you've got C8H18, C8H18. We had 10, we've used 8, we've got 2 left. We had 22, we've used 18, we've got 4 left. We could have done it that way, but I know what ethene looks like, so I know it would have looked like that. State 2 conditions for cracking alkanes. So I am having a cracking time playing cricket on a sandy beach. If I can spell beach right. Someone throws a very light metal ball at me, and then I hit it for a 6. Okay, now the reason I remember that is sand is silica or silicon dioxide. I tend to remember silica. Right, light metal, and it's light. I think of aluminium, and it's alumina, and alumina is aluminium oxide, and hit it for a 6, so that reminds me of 600 degrees C. So you can get away with anything between 600 and 700 degrees Celsius. I just remember the 6. So the 2 conditions are silica or alumina and 600 degrees C. They will go there. Right. What is an isomer? An isomer. So remember an isotope are elements. Let me start that again. Atoms of the same element that have different number of whoa, what's going on, dude? Let me start that again. Protons, I keep writing out protons. But oh my god, what's going on? Different number of neutrons. I'm losing the plot. But have different number of neutrons, but the same number of protons. Okay. So if you look, that carbon has CH3, that carbon has CH3. This carbon doesn't. This carbon has both the CH3, so it's an isomer. Right. The reason is they are isomers, so that's an isotope. Before I lose the plot. So these are molecules that have the same molecular formula but different displayed, or you can say structural. Okay, there you go. Draw a diagram to show the structure of alkene. That is another isomer of these two compounds. Structure of an alkene. Right, okay, 3, 1, 2, 3, 4 carbons. So I've got 4 carbons. 1, 2, 3, 4. Right, okay, I've got a double bond. So I could do this. Right, and how many hydrogens did I have here? Let's have a look. 3, 6, 7, 8. I had 8 hydrogens. I've used 2. So let me put 3 here. 5, 6, 7. I need 4 bonds on each carbon atom. Look, 4 bonds. I've got 1, 2, 3. So I'm only allowed 1 more hydrogen here. And if I count the number of hydrogens, where are we? Let's start here. 1, 2, 3, 4, 5, 6, 7, 8. And I had 8 here originally. 3, 6, 7, 8. That's fine. So I've drawn an isomer. So an isomer. Yeah. There's a difference between an isotope and an isomer. Right, let's move on. What's next? This is the structure of propene. How many carbon atoms? Let's have a look. 1, 2, and 3. The propene can be polymerized. Give the name of the polymer formed from propene. Polypropene. Polypropene. Okay. Draw a repeat unit. Right. Methane, ethane. Let me do it here. I'll show you. This is interesting. Methane, ethane, propane. Right. It's propene, so I've got a double bond. Right. So I've got 1, 2, 3, 1, 2, 1, 2, 3, 4. Now the way they tend to draw it, I'm going to move this up here. Yeah. Let me rub that out. So I'm going to move this CH3 up there. What's happened is that CH3 has gone here. And now you've got 1H here. I should have finished that off. Right. So this is the molecule. All that's happened is I've moved this from here up there. Now what you do, this bond is going to break. you're going to end up with 2 bonds here. That is the repeat unit for polypropene. So what I do is I do this. Which way? Okay. I've drawn it the other way. Look, I've drawn it there. So let me cheat. Let me move that because we don't want it to be right. Okay. Oh, I don't know. I've just left that behind. Right. Can't believe that. Right. Okay. I'm gonna add a H here. Right. So now that matches that. So I'm gonna have to draw a CH3 here, a H here, a H here, a H here, and that double bond that was here breaks up and goes that way. So this always caused me confusion. It's the repeat unit. Yeah. So the repeat unit of an addition polymer. Remember, there's a few different types of polymers. There's condensation, there's addition, and there is substitution. This means you get 2 products. This means you only get 1 product. This means some atoms are substituted. Draw the structure of the monomer used to make this polymer. So that, right, we need to, so what's going to happen is, can you see this double bond? And this double bond is going to go back there, and that's it. That is literally it. So what you're going to do, we're going to do that. We're going to do that. No, we're not going to do that. I lied to you. I was being lazy. My fault. So I'm going to do this then. I'm just going to copy that. So this is what you've just got to remember what to do, yeah? And then just copy it. So can you see all we've done is we removed them 2 original double bonds, made this into a double bond, and that's it. There you go. Right. Propene reacts with bromine. Which of these formula of the product? So when you get propene, when you get an alkene reacting with a halogen, you're going to end up with Br2. Right, okay, so you're going to start with this. Meth, eth, prop. So these are hydrogens here. Right. We're going to add bromine to it. I'm going to split it up like this. So what's going to happen is this double bond's going to break. I mean, to be honest, it can go anywhere. But let me get rid of that. Right. So now what's going to happen is you're going to get an extra bond there and an extra bond there. You're going to end up with Br, Br. Right. There you go. So this here is the formula. So you've got, they've all got 3 C's. 3, 4, 5, 6 H's. So it's going to be, it can't be that one. You've got 5 H. Okay. That's it. 6 H's and 2 BR's. So it'll be B. That's how you can do it if you don't know. Draw the polypropene. Draw the displayed formula for propene. So I think methane, ethane, propane. See, I just did it. Right, okay. So I can do it like this. Let me get rid of that. I do too much when it comes to that. So let's carry on. Do. So each carbon atom's got 4 bonds. You've got hydrogens. Do not forget the hydrogens. I'd be a bit lazy when I'm doing these, but I shouldn't be. Because if you miss them out on the day, you might lose marks. So be careful. So make sure the hydrogen atoms are clear. Draw the repeat unit of propene. So now what's going to happen? Right, watch this carefully. Can you see the way I've drawn it? This is going to move down to here. So now I've got, let me go up. So now I'm going to draw it here. Look, I'm going to draw it here. I should draw it here, but it might be easier to see. So what we do is, right, I'm going to draw the C, the H. I'm just going to draw the double bond for now. I've got a H here. And I've got a H here. So this bit I'm going to draw down here. Right. Now, look at this double bond here. That's going to break. So let's delete that. No, no. Okay. Then, oh, did I just do that? I did. So what I'm going to do is that double bond's going to form 2 bonds there. And this I can write as, let me just move that to the side. I can move that to the side and rewrite that as CH3. So can you see this is CH3? So that is my repeat unit. Let me just figure that one out. There you go. There you go. There you go. There you go. Right. Crude oil is a, what is crude oil? It is a mixture of hydrocarbons. Of the process called fractional distillation, breaks it down into fractions, and then cracking can break down large hydrocarbons into small, more useful hydrocarbons. What property of hydrocarbons is used to separate crude oil? Well, it'll be the boiling point. They have different boiling points. Then they'll evaporate and they'll go up the column. It's cooler at the top. So look, you've got to know this. Here's your fractionating column. Right. These are where the different fractions come out. That's where the crude oil goes in. You have to heat it till it vaporizes. It rises up. It's hot at the bottom. It's cooler at the top. And the lower, smaller boiling point hydrocarbons will evaporate first. They'll travel up. When they reach their boiling point, they'll condense and they're collected here. Right, so we've been through all that. Next question. These are the main fractions obtained from crude oil. Right, okay. Refinery gases, that is used for camping gas. That's the best word I've found out. Camping gas. I call it cooking gas or stove gas, but call it camping gas. And kerosene is for planes, but if you put for planes, you will not get a mark. It is fuel for planets. State which fraction is the most viscous. This is another word for not runny or thickness. If somebody calls you viscous, don't smile at them. Bitumen. It's the most bitumen. It's the most viscous and it's used for making roads. Right. Catalytic cracking. So this is catalytic cracking. Remember, I'm having a cracking time playing cricket on a sandy beach. So I think of and somebody balls with a light metal ball, so I'll say alumina. These are the two catalysts, and then the ball, and I hit it for a 6. So I remember 600 degrees. Name the catalyst. So silica or alumina, any one of these two. Any one of them two will go there. State the temperature. There. Tetradecane. 14 carbons. Got 14 carbons. Can be cracked to make ethene. So your C14H30 becomes C2H4. Now I had 14 carbon atoms. I've used 2, so I'm left with 12. I had 30 carbon atoms. I've used 4. I'm left with. There you go. Displayed. Right, again, ethenes come up. Look, always comes up. So just remember, ethene has got 2 carbons and 4 hydrogens. You can draw it like this as well. But do not forget to put the hydrogens on. If you do, you might lose loads of marks. Name the polymer formed from ethene. It's gonna be polyethene or polythene. But best way to do it is just put polyethene with a bracket around it. Explain why this is difficult to dispose of. Because it is... Okay, it doesn't biodegrade. It's a 2 marker. It doesn't biodegrade. So it cannot be broken down by bacteria. Right? So what I would do with this sort of question, write down it is inert. So doesn't biodegrade. Which means cannot and can't be broken down by bacteria or fungi. Remember what we said. There's 2 decomposers. Bacteria and fungi. Okay, let's go. Chlorine is used to manufacture in the manufacture of the addition polymer polychloroethene. Explain how addition polymer is formed from its monomers. So what you do is you say many small monomers join together to form a long chain polymer. Many small monomers join together to form a... Right, or you could say many small monomers break the double carbon to carbon bond, join together to form a long chain single carbon to carbon bond polymer. Right, with this one, look at this. When they use the word N, that means there's lots of these, right? Polychloroethenes, and what you do is automatically draw a square bracket, put an N there, put a carbon there, a hydrogen there, a hydrogen there, a carbon there, a chlorine there, hydrogen there. The double bond breaks, so this, we don't need a double bond, we just need a single bond, and then extend this past. That's it. That is a repeat. Alright, we're drawing the equation for the displayed formula for polychloroethene. Whilst this was a repeat unit here. Can you see that? There's no square brackets and what have you. But I would always put them as a backup in case you misread it. Okay, let's have a look. Where are we? We nearly finished this. Yeah. So let's get this done then. Complete the equation. So we need to draw a polymer. So square bracket. So remember this was the clue. N C C H H H H. This double carbon to carbon bond breaks and you extend it past the square bracket. Right, why is it called an addition? Because only one product is formed. Remember what we said, there's different types. There's addition polymer, substitution polymer, and you've got a condensation polymer. There you go. Right, many shopping bags are made of polyethylene or polythene. One useful property is that it is inert. Right, it is strong, so can hold a big weight or can hold shopping without breaking. It is light. It's light. Oh, okay. Low density, so it does not weigh, not heavy when used. Does not react with food, so it's non-toxic, so can be used for food. Waterproof, flexible, it can be recycled, it can also be transparent so you can see the contents. Another property of polyethylene or polythene is that it is biodegradable. Right? We can dispose of it using a landfill or burning. Give one. We are running out of space in landfills. Right, that's one problem with that. And burning will, the standard answer to this, it produces toxic gases or poisonous gases or greenhouse gases, and that's not good for the environment. Right, well done. If you got to the end of that, that is that done.